Okay, so today we're going to talk about right triangles and angles inside of circles. So we're still dealing with the same standard. You're going to learn how to find the measure of arc given a right triangle and the radius of a circle. Interior angles mean angles inside of the circle. The intersecting arc is the arc that is in between the angle. And we're going to do a quick review on our trig ratios. Alright, so if you remember, we talked about our trig ratios. Some old hood rat caught another hood rat taking off Adidas, or SOHCAHTOA, where sine theta equals opposite over hypotenuse, cosine theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. So there you go. That's your trig review right quick. And now let's jump into a problem. It says circle W has a radius of 5. What is the measure of arc AB? So I need to answer this part of the question. So it's asking me to find the measure of this arc in degrees. So I'm going to highlight this part here. So I need to find this. And the second part of this process is to identify what is given. So circle W, that's the name of this circle, which is normally in the center of the circle, is the name of the circle, has a radius of 5. That's really important. So that's telling me that from the center of the circle to the circumference, which is a radius, that is equal to 5. And I'm going to highlight that in yellow. Well, I'm going to do it in yellow. It should go yellow. Well, I'm going to do it in red. Alright, so that's the radius, or the radii, and both are 5. So I'm going to write 5 on this side and 5 on this side. And if you notice, this is a right triangle right here. This is a right triangle. So I'm going to go on the side and draw it. So whatever I find on one side will be the other side, because they are congruent right triangles. And this is asking me to find this arc. Well, if you look here, this is a central angle. So if I find this angle, then I know this angle. And if I know these angles, then I know it's intersecting arc, because the rule says that the central angle is the same as the intersecting arc. So if this is A, then this up here is going to also be A. They're going to equal each other. And I'll call it B for the sake of understanding. I'll call this B right here. So A equals B in this case. So part of this is this angle right here. I need to find this angle. So I'm going to use my trig, because this is a right triangle. And so I'm going to put my finger on this angle, or you can just mark this angle. The side that I'm touching is the adjacent side. The side that's across from the right angle is the hypotenuse, and the side that I can't touch is the opposite. So we're looking at what we're giving, which is adjacent and hypotenuse. So if I write down my SOHCAHTOA, I need to figure out which one of my trig function has both adjacent and hypotenuse in it, and that's cosine. So I'm going to say cosine of, and I'll call this x, since that's what I'm looking for x equals adjacent over hypotenuse. Alright, so if I draw my little trig circle, then the cosine goes here, cosine of x goes here, the 3 goes here, and the 5 goes here. If you need a review on this, go look at the trig videos. I think they were sometime in November or December. Just check YouTube out and go re-look at those if you need to. So I need to find my angle here. So that tells me to go cos. That tells me that x equals the cos inverse, because anytime you find an angle, you want to do the inverse of it. So cos inverse equals 3 over 5. And let's go get that. So you grab your calculator. If you're dealing with a graphing calculator, check your mode, even with your scientific calculators. Check your mode and make sure it's in degree and not radians. Okay, so I'm going to do second cosine, and I'm going to do alpha y equals, and put in 3 over 5, close it up, and push enter. And my angle here is going to be 53, and I'm going to round to the nearest tenth, 53.1 degrees. So if this side is 53.1, then so is the other side 53.1. And if I add those two together, then we get 53.1 times 2. Let's see. Equals, that's 6.106. And I'm going to double check my math to make sure I'm good. And you can use this skill to always double check behind yourself. Make sure you're good. So that's 106.2. So this angle, so this arc AB is equal to 106.2. And I can say that because this is a central angle. So this is 106.2. All right, and we are finished with that one. Okay, so let's tackle the next one. It says circle D has a radius of 9. Find the measure of angle ACB. So I'm going to highlight the question part. This is what I need to find. So let me go into my question here, my picture. So it wants me to find this angle right here. A to C to B. So I need to find this angle. And if I notice, this is an inscribed angle because its arc, its vertex is touching the circumference of the circle. So I'm given that this is a circle D has a radius of 9. So from the center of the circle to the circumference of the circle, I get 9. So this is 9 and this is 9. So now I need to come up with a plan. So I've got what's given to me and I need to come up with a plan here. So here's what I can find out. I know this is an inscribed angle. The intersecting arc for this inscribed angle is AB. That's this up here. That's an intersecting arc. So if I find this piece in black, this central angle, then if I know this central angle, then I know the measure of this arc. And the rule tells me that if I know this arc, then I can go and get this angle. So I'm going to pull on my trig again. I'm going to draw this right triangle. And I know that if I find this angle, then I automatically know the other angle. So this is 7. This is 9. This is my right angle. And I'm going to take an object, or you can take your finger, put it right here. The side you're touching is the adjacent. The side across from the right angle is your hypotenuse. And the side you can't touch is your opposite. Okay, so now I need to look at my SOHCAHTOA. The side that that's in between the two angles that I want to find, the angle I want to find, which is x, that is going to be cosine. So I'm going to say cosine of x should equal 7 over 9. I'm going to draw my little trig circle. Cosine of x goes here. 7 and 9 goes here. You're trying to find that x. So you're going to do cos inverse of 7 over 9 should equal x. And once again, if you need to go and review the trig, it's perfectly fine. Go watch that video and review how to work your trig problems. And anytime you find an angle, you always do the inverse of that trig function. Alright, so we get 7 over 9. And that's 38.9 degrees. So I know this little piece here is 38.9. And so is this 38.9. So I'm going to go and say, well, I need to add those two angles together. 38.9 plus 38.9. Give me just a second. I'm trying to straighten this out. Let me move this over so that it's not colliding with our problem. So if I add those two together, 38.9 plus 38.9 equals 77.8. So that angle is 77.8 right here. That's that central angle. So that means the intersecting arc is 77.8. And there's a rule for finding the inscribed angles. So if this is the intersecting arc, then if I take half of it, then I'll know the inscribed angle measurement. And here's how I remember. The arc is bigger than the angle. So I have to get half of it to get this angle here. So that means the measure of angle ACB is equal to 77.8 divided by 2. So that tells me the measure of arc ACB is equal to, divide this by 2, and that's 38.9. And we are finished. So this here, 38.9. And you got it. Alright, so go through, complete the rest of these problems, and I will see you guys in class tomorrow. Alright, bye.